Hey, thanks for joining me. My name is Phill and I'm presenting with GridMarkets and also some Houdini action to show you some super detailed ink simulations. So the images here are different simulations I've done, rendered in Houdini, all rendered with Mantra, and I rendered those on the cloud service GridMarkets. So just a background on myself, I am an FX Arist, and I'm currently working at the Mill, Los Angeles, and I do everything from explosions to destruction to, I don't know, it's an effect, probably done it before, lots of different stuff in commercials. And definitely Houdini is my tool of choice. It's very flexible, good workflow, and you can do a large range of different effects in it. And besides doing just normal commercial work, I also enjoy kind of working on things outside of work. The image you can see here, the kind of like fluid tank, that was a good, fun project. The only downside though is it took about over a week to render. So I've really been enjoying using some GridMarkets for cloud rendering because you can really speed up your workflows. And so I'm going to get right into the actual ink simulations and renders. Here's a still from one of the more high quality ones. Lots of Houdini users out here. I don't know your guys' experience level, but a render like this has got hundreds of millions of points and can take, on a home computer, probably anywhere from 4 to 8 days. So here's a number of different kind of experiments I've done with the actual ink simulations. So most of these are using a very similar type of actually fluid setup, and I'll show some demos on that in a little bit. But the main difference is kind of the curves used to drive the forces. Other than that, it's really a very similar setup. So a great example of how Houdini is very flexible and that you can have the same kind of base setup and really end up with all these different kinds of looks. And actually be getting into a little bit later in the presentation, I'll show you how I do all the different colors for it. Most of the colors come out the same on it, and then you can really dial in your look at the end. And this last one here shows you kind of my color workflow from a blank render to color out of the box, and then also the comp color you can achieve in the end. First main thing you want to get to when you start doing an ink simulation like that in Houdini is you're going to end up having to set up your emitter. So in this case, I've been driving all the ink simulations by a curve that I draw, and on this curve it really defines kind of where the ink comes from and where it can go. And on the right you kind of see the points that are trailed on that emitter. Once you have your kind of emission source set up, you can do your overall volume smoke simulation to get your motion set up. And you can see here the picture of the smoke. That was the last render you saw, and there's kind of the dot network on the right you can see. I'll be getting into that. So once you establish your motion, you'll move into getting your details, and to achieve detail you're going to be affecting millions and millions and millions of particles. I think the highest I went on the simulations is about 300 to 500 million, and about that you have roughly 200 to 500 gigabytes of data each simulation. So cloud rendering is definitely advantageous in this because I did most of these on the laptop that are submitted from it, and I can't even open up the files that the cloud's able to do. So it's really helpful for high quality work. So once you set up your sim and you have a good look for it, you can go ahead, and this is my ROP tree in Houdini, and it does all the dependencies for me, so I can kick it off, go to sleep, go to the beach, do whatever, come back, and I'll have images. And this is the window when you're submitting it. And it's really cool because I'm able to generate all these like gigabytes and gigabytes in the cloud, and all I have to do is submit a little 7 megabyte file. So once you get it all submitted, this is the render window from GridMarkets. You can see it's in progress, and most of them were completed. And yeah, the frame time's pretty good. It's about 20 minutes for most of those frames, so really quick. And once you get those images back from the cloud, I'll show you a little COPS workflow to kind of dial in your color on your actual sim. So most of the render was done in white, so that you get your lights and shadows. This is the raw color that you get out of the render, and then I was able to kind of pick different color schemes in COPS after the fact and kind of preserve my lighting that way. So let me go ahead and jump right into Houdini. So like I mentioned before, this is the paths that I've been emitting the simulations off of. I have just kind of a simple little spiral tool, and this is a nice way to kind of figure out different looks, build a different spiral. You change the frequency of that. So all the different ink sims were mostly done by setting up this whole setup and then just kind of changing the curve that I was emitting from. So once you have the curve that you like, this is the actual object that's moving along the trail that's emitting from. And when I zoom in on it, it's super, super tiny. I don't know if you can even see that up there, but there are these little tiny points on it. And part of this emission scheme is how I was getting that really high frequency, almost kind of stringy detail. You start off with these really small lines, and then over time they kind of get pushed around. So you can use the position and keyframes at object level to translate your emitter on there. You can see how I just keyframed it over time. Just fly through and it moves along the curve. Again, it's really small, so you're not really missing too much. So after you have set up the emission along the curve, you can merge that into here, into another object. And I'll usually do that so I can trail it and calculate its velocity. So now you can actually see the object here. If I look at it, it's got velocity on it. I want that to help drive the simulation. And mostly after that, I'm kind of setting up this curve. So I have basically a trail along the curve over time. Then I'm turning that into a rough polygon, converting that into a NURBS curve so it's nice and smooth. And then what I'm doing is a resample on it, so that way no matter how fast the actual emitter moves along the curve, you get a consistent high quality point result. And that really makes it really nice for fast moving objects. You don't need to worry about catching detail on it because it just resamples as much as you need it to. So now I'm ready to go into the actual DOM simulation. So I'm building a source here. And you can see I have the volume I'm going to emit from. It moves along that curve, so that's all working. So I have my source for density. You can also check out the velocities that I'm going to emit from. So that's all working. Just making sure all my attributes come out from points and get into volumes. And then this is the other thing that I'm going to use in my simulation. I'm scattering just 2 points every frame, and I'm going to emit these points in the simulation as vorticals. And I'll get to that in a second, but just setting up the emissions for it. So moving right along into the DOP portion of it. So our source is all set up, and I'm going to turn my resolution down a little bit to try to show you some stuff interactively. This is what I was simulating at production level. I'm not going too high on the volume simulation. You want something kind of reasonably quick to kind of get a good idea of your motion, but again, you're getting all your details from points. So you don't need to worry about having a super high quality volume. Again, it's kind of good to be able to preview this quickly. So I can play back. It takes a little bit. I'm on a laptop, but it's definitely good enough to get an idea of kind of how this ink simulation is going to turn out and look. So the emitter is moving along the curve, and you notice that it's falling down. Usually if you use a pyrosim, which I actually based my setup off of using the pyrosim, it rises. So I'm usually going to the actual simulation tab of the pyro and setting my buoyancy direction in -y, so it sinks kind of like ink in water. And I've also found that mixing in a little bit of viscosity with your smoke can also help to kind of hold it together and act more like a thick kind of like paint-like ink in water. And in terms of other simulation options, I'm not really doing too much. A little bit of confinement to add kind of vortex motion to it, and also a little disturbance. Not on velocity though, I'm doing disturbance on temperature. And usually when you do disturbance on, it'll kind of push and pull things up and down. I've actually gone into the pyro solver and changed the disturbance so that it only makes it sink, nothing rises up. So I don't know how many of you kind of work with microsolvers and DOPs. It's a little tricky, but Houdini's so nice in that it's very open. So as soon as you go in there, you can kind of tweak as you see fit. So this is the whole network in VOPs, how you're driving that. So you can actually just turn off this negate and you won't get any negative values, so it'll only sync. So this is kind of a little trick to kind of direct the disturbance on that, and just kind of really direct what kind of simulation you're going to get. So most of that's pretty standard pyro, except for I'm adding in vorticals, which I mentioned earlier. So I have a couple points where I'm sourcing from, and then I'm emitting these vorticals into the simulation. And when I add those in, they kind of help stir things around quite a bit. So here's the geometry for vorticals. They're being affected by velocity. And then one other thing I'm doing is I'm using a SOP solver in DOPS. And I'm merging in these points that I set up in SOPs and just copying on their parameters for magnitude. And the only other thing I'm doing that's kind of different is that over time I'm changing their radius and force over life. So I noticed that if you leave them all really strong the whole time, they kind of tear your sim apart too much, or you kind of end up with weird kind of looking things. It's kind of nice to kind of ramp it over time, and again, just really get in there and art direct it. So that's the overview for kind of the volume workflow. I'm gonna put this one setting back. I turned it a little bit too high. So give this a quick little play, and this is doing, again, what I wanted to. And the cool thing about this is that once you have a good look of the volume locally, you can pretty confidently submit this off to the cloud, to GridMarkets, and you can get the very similar look with particles of the volume since you're affecting it. So let me show you the next step. Once you have a good dot sim, I'm going to go ahead and import that back into my scene in objects. So I'm fetching all my fields from DOPS, just density, velocity, and temperature. Those are the ones I'm using. And right here I have a GridMarkets cache node. So it's very easy to kind of add that to your scene. I was actually working with a file cache that I have at home. I know studios have their own file caches. So I have some switches here so I can very easily switch between working at home or working with GridMarkets. It's effortless. I just flip a switch and I can go from my home computer to the cloud. It's very simple. And there's a few options on the cloud cache. For the most part, you can just leave it alone, and you can do a spawn in rocks. So when you click this button, it'll create an output node for you. And here's a duplicate one. I already have one, so I don't need that. But I have the first step is the volume, which I was showing you. Then after you do the volume, you can cache out your points. And this is the switch I was mentioning between local and the cloud cache. So just by flipping this, there's a few referenced switches in the scene. So either I can render at home or I can render on the cloud. Again, it's very easy to go from just a batch render locally or then go to actual render submit for GridMarkets. So got volume, points. Now here's an output node for points. I need to show you how the point advection works. Here's the volume again that we were looking at. And I'm going to put a trail on it so you can see kind of funky shapes coming off it, but you can see there's a lot of vortex motion in there that I'm getting on that, and that kind of helps me get all the nice like swirls and vortices in the actual ink. So already visualizing that, we're going to get a pretty cool result. So that's the volume. I'm just using that in my pop sim. So again here I'm importing that guide curve that I made, and to get the color of it I'm putting a box around it, and I'm calculating color based on bounds. So if I plug the curve into here, you can kind of see the color on it. Make a dark background, you can see that a little bit easier. So when I emit the actual ink color from this curve, it's going to pick up this color, this kind of rainbow color I have, and I'll be able to drive that. It'll flow through the simulation, and I'll be able to drive that in compositing later on. So pretty much doing what I was doing to make the source for the smoke earlier is that I'm just kind of trailing that, connecting a few points up, zoom in here. Again, it's really small because it's really detailed. I wanted that kind of high frequency detail in the ink. Connecting these up to make a curve, converting it to NURBS so I have a nice smooth curve. And then again what I'm doing is I'm resampling this curve. And this is this resample right here is kind of the detail quality level that I get in the end ink simulation. It determines how many points I'm going to emit at each frame. And right now the length of the points, the distance between each other is 2e-5, so it's like 0.000002. It's very small. So if I turn on the point view, it pretty much looks like a continuous line. You have to keep zooming in to kind of see any kind of point separation. So if you're doing really detailed kind of ink simulations, it helps a lot of having just millions and millions of points, as well as you have a quick moving object. You don't get any steps with it. You have a nice kind of continuous flow. So here we go into the pop simulation. And very simple, just sourcing points. And I'm doing a pop advect by volumes. See if we can get a couple frames going here so we can see our result. Okay, so we can see we have a little swirl coming down from that. And I found that the best way to use the pop advect is set to update position. When you update a force, you're kind of changing your velocity, and it's hard to kind of really match that exactly to your volume source. So when you update position, it's just directly pushing the points around by your volume, by your velocity field. So again, it's a very good way to get a one-to-one result. If your volume moves like this and looks like this, you will get that with your points. The only other option I've changed on the pop advect is the advection method. I found a single step it'll get the job done, but if you use some of the different advection methods, you can get even more detail. And I think my personal favorite that I found, just look-wise, getting nice high-frequency detail and kind of keeping that stringy swirls in the ink, is using the trace RK4 method. It is a little bit more expensive, but you get what you pay for. So if you want lots of detail, I can kind of help you out. Other than that, it's really just standard pops of just pushing them around and getting that look. So once you come out from pops, the other thing that can happen is when you're doing an advect by volume and you are updating the position of the points, you don't actually get a velocity from pops. So I'm just using an attribute for volume to directly copy on my volume's velocity right onto my points. So that way, again, just whatever the volume does, the points will do. So it's very easy to develop locally on your volume and then submit to the cloud and get back the expected result with the points. So after that, I'm really just setting it out right here and going into my final preparation for point rendering. So I have a render object here for my points. And all I'm doing is object merging in from that point preparation I did. And I'm clearing off any extra attributes I don't need. Because again, when you have 500 million points, any extra attributes like you're not using like color. I'm using color and life, but if it has any extra attributes, it's going to be really expensive in terms of disk space to have. So might as well just clear them off. And again, too, before I kept setting the point color in the actual points and in render, but again, I like this new kind of workflow of keeping my renders as pure white and then modifying the color later on. So it just ended up to be a lot more flexible, a lot less re-rendering. So again, I have another GridMarkets cache node. So the cloud will save out all these files on the cloud and then render with them. They don't need to come to my workstation at all. In fact, I copied one from the cloud after I was finished, and it was so big that I couldn't even open up my laptop. My laptop just crashed. I think it took about 50 gigabytes of RAM to simulate that. My laptop only has 16, so you can imagine it just wouldn't work. It's much more powerful than my laptop, so it was really nice. And one other quick tip is that when you read in your files for rendering and it's really heavy points, I really like the load as packed disk primitive option. It'll keep your scene nice and light and it won't copy your geo. When you go to translate and render, it'll just read it off disk. So that's a good tip to kind of speed up your rendering workflow. So the final step, now that I have the volume and point cache all set up, is to actually submit that to the cloud. And I also have my render. So go from volume, points, again switch local or cloud, I have it on the cloud setup. Here's my render, and then I can go submit. So what this is doing now is it's looking through my entire scene and calculating every dependency that I'll need to run on the cloud, so I have all the same, if I have textures, models, all that stuff. And since everything is procedurally generated in Houdini for this ink scene, it's very light to submit. There's like some extra caches and stuff on here that I wouldn't be submitting normally. So if you're looking at the pre-flight window for the cache, you have this kind of upload and download category. So basically what you're uploading and what you're downloading. So uploading my scene file, I don't need, these are renders that I got back. So if I were to submit this right now, it's only 6 megabytes that I upload. It's going to go in the cloud, simulate the volume, that'll be about 100 gigabytes. It's going to go simulate the points after with that volume, that's going to be probably about 500-600 gigabytes. Then it'll go to render. It'll render in about 30 machines, turn all that data into EXR images with all my channels and colors in it. And I think when I download it's probably about like 3 or 4 gigabytes back. So I skip a huge portion of all the data required locally to make that look. So I'd hit save and continue. In this case I'm going to hit cancel, because I already have the images. And I don't know, do many of you use COPS? I haven't used COPS a ton, but I found it a really nice tool for kind of getting a quick idea of how my renders are working, and it's native to Houdini, so you can even chain up a comp render in your ROMs and go straight from simulation to render to composite, and you can even make a movie with it now, which I've seen is really cool. So you can, in theory, not even have to do any work locally with it. All right, so let's load in some of these renders that I have. I'm going to turn off DOP simulations. All right, perfect. So here's the final result, which you viewed in the video earlier. This is the actual render that I get, the raw render. So it doesn't look too interesting, does not look like the result hardly at all. I have color right now is just the diffuse lighting. It's got the alpha, pretty standard. I have PZ, which is depth. So you can kind of see with the hit eye, you can get the inspector and see what depth and space that is. And finally, I have my own custom color that I baked in. So this is the color that I acquired from the bounding box. So basically wherever it's emitted, it'll pick up the color in that quadrant. So if it's emitted in a different part of the box, it'll have a different color, and then that data just sticks with the particles and they kind of move around over life because they move around in that ink simulation. So the first step I'm doing is just kind of adding a little bit of contrast to the diffuse lighting itself. And on this side of the stream of COPS, I'm copying over the actual color channel I have. And I'm using the hue saturation node. It's pretty cool. You can swing around the colors however you feel like. I'm also doing a color correct after to kind of get these nice like reds. But again, it's very flexible. You can kind of push this around however you want. And the best solution I found is to actually multiply the chosen color against your original render. So that way you preserve all your lighting highlights, but then you can really direct your color. And then there's also a cool depth of field you can do. So on the actual depth of field node, this makes a mask to use with a defocus tool. And once I do that, I can, the depth of field is nice. It kind of helps it feel more like macro, ink and water kind of look. And you can set it really shallow. It's again, it's not using deep compositing. You can only go so far with the depth before it starts to be kind of like edge artifacts. So it's good to use sparingly to kind of develop your look, but don't go too far with it. And then this is the background that I'm putting it over. So it's just a solid color, and I have a radio ramp. I'm using this to drive brightness. So darkening of the edges, little vignette. And then also this is just a vertical ramp. And again, kind of darkening out to kind of fake a little bit of lighting. So you can see that you really start with a very raw render and you can really tweak the look of it. For example, if I decided that I didn't like this color scheme, I was going to go a little bit different. Kind of swing this hue around and go in here, and then maybe instead of a red, I go for like a blue look on the fluids. Some green, and then change the background color too. Let's go for more of a deep red, purple. So you can see how quickly I can really change the look of that without doing any other re-rendering, just by saving out those channels in the EXR images. So here's kind of a comparison of different color schemes and different emission schemes from that as well too. So this is again that final ink render that we saw that was kind of developing in COPS, and here's the final result. And again, these are the different stages of compositing. You go from raw render, colors just from a positional attribute in the scene, and then kind of really getting in there and art directing the colors. So definitely what I've learned from working at home is that you do have very imposing limitations, especially if you only have a single computer. Again, if you're doing simulations, you're generating terabytes and terabytes of data. Becoming more of an engineer and IT support instead of focusing on doing artwork, and that can become pretty tedious fast. You're just trying to work on a cool project. Also too, if you did end up having a ton of machines at your house or something, if you have all these licenses and all these machines and you're not using it, it can be very expensive to have not used. So again, I've really enjoyed having a GridMarkets type workflow where you can just set up your scene in Houdini, work natively, send it to the cloud, and pretty quickly you'll get a result back and just really don't have to worry about all the technical stuff. It's handled for you. And again too, this is the ROP setup that I've been using. Using dependencies with GridMarkets is really helpful in that you can do all your steps automatically, keep all your really heavy data out in the cloud, not at home, and then just get your images back. And again, I was able to work from my laptop and my tethered cell phone to do all that rendering. I didn't need workstations or anything else, so you can be really flexible where you're at and how you do it. It's a very nice workflow. Anyone have any questions about workflow, Houdini, GridMarkets, anything?
GridMarkets, can you send simulations, like not just renders?
Yeah, so I was actually doing, simulations. So in my ROP tree here, there's like a cloud cache node. You can download an OTL from their website, and it has the tools for it. And when you send it to the cloud, this is actually a smoke simulation, and then dependent after, it's a pop simulation for particles, and it's pushing the particles around by the actual smoke sim you did first. So then there's also an option to check for that it's a simulation, so it knows to run on one machine, does the other one on one machine after, and then it'll distribute your renders out to a bunch of render nodes. So it's been really good for simulations. A lot faster than my laptop as well too, which is great. Any other questions? All right, great, thank you.